All right, folks. Hello. We are going to be doing the last chapter or the last section in our chapter 5. All right, that is 5-5. It's the last one we're doing, not honestly the last one in the chapter. It goes to 5-8, but we've already done that. So we're doing 5-5. Solving right triangles is what it's titled, but that's really misleading because it is using right triangle trig. It is using the sine, cosine, tangent, all that stuff. But we're really looking at evaluating or solving equations involving those trig ratios. And we're going to look at examples to show you what they might ask you. So I'm going to just not waste any time here and go over to the notebook and start looking at some examples. All right, so first example will ask you, let's see, the way they do it is they say evaluate the equation. They might also say solve. Evaluate the equation. And then they'll say assume that x is greater than or equal to 0 degrees and less than or equal to 360 degrees. So one rotation. And they'll give you a problem like this. This is your equation to solve. Let's see, tangent of x equals 1. And so there's a couple ways that you can do this. One is just by your immense knowledge of the unit circle, now that we've done that, or you can use inverse trig functions. When I say inverse trig functions are things like sine inverse, cosine inverse, tangent inverse. They're also called the arc functions. You can write them either way. And what those tell us is, say, for example, tan inverse would be the angle whose tangent is. That's the way we would read it. So we can do this in a literal fashion with our math skills and say, if I look at this side, I want to solve for x, so I got to get x by itself. Well, I could take tan inverse of this side. But if I do that, of course, I've got to take tan inverse of this side as well, because that's how equality works, right? Now, what this means is the angle whose tangent is the tangent of x. So if you're asking about what angle has a tangent, that's the tangent of x, it would be x, wouldn't it? Doesn't that just unwind itself, so to speak? Right? So this side becomes x. This side is tan inverse 1, the angle whose tangent is 1. Well, again, you might know this right off the bat, and I'm going to talk about this in just a minute because you kind of need to know unit circle regardless, because what you can do right now is you can go to your calculator, making sure you're in degree mode. As usual, we said assume up here, it told us assume x is between 0 and 360, so we are using degrees here. And if I punch in tan inverse, which is right above your tangent key on your graphing calculator, tan inverse is just second tan, and then put 1 in. If you do that, it will tell you x is equal to 45. That means, of course, 45 degrees because we were in that mode. But it said evaluate this equation assuming that x is between 0 and 360. What is we've found where, whoops, that's supposed to be a little bit better drawn than that. Let's do this. If we have, I went back to that. All right. If we have our unit circle, and I'll draw that real quickly. All right. So if we have our unit circle and we're looking at this, it's telling us at 45 degrees, we have the tangent of 1. Now that makes sense because if you think of what's happening here, when we talk about our x and y values, remember we said on the unit circle, this was root 2 over 2 and root 2 over 2, right? That was our 45, 45, 90 special angle. So in other words, our cosine and sine are the same because tangent is sine over cosine. When they're the same, tangent would equal 1, right? But it said we were looking at this as we go entirely from here all the way around back to 360. So is this the only place that tangent would be equal to 1? Well, if I'm asking it, you probably know the answer is no. Because if we think about this 45 relationship, we have another 45, 45, 90 here, another 45-degree reference angle here, another 45-degree reference angle here, right? Now, this 45-degree reference angle does not have a tangent of 1. This has a tangent of -1 because this is in position negative root 2 over 2, root 2 over 2. So this would be, when I put sine over cosine, remember y over x, root 2 over 2 over negative root 2 over 2, I get a -1. So this has a tangent of -1. Now this one here has the position negative root 2 over 2, negative root 2 over 2. So when I do sine over cosine here, I do get 1. So there is another solution. 45-degree reference angle, again, we're looking at the entire angle. It's a standard position angle. So it would be 45 added to 180. That would be 225 degrees. So we have a second one. Over here, what do we know? We know that this is root 2 over 2, negative root 2 over 2. So again, here, the tangent, they're the same quantity, opposite signs. So we look at, this would be a tangent of -1 as well. So for tangent equal to 1, we have two solutions in that range from 0 to 360. All right, so that's our first one. Let's do another one. Let's see if you get the hang of this here. Let me get a new color. All right. So another example. Let's do sine of x equals -1/2. Now, again, we could take the calculator approach, but the calculator approach, I hope you saw the weakness of it in that first problem, is it doesn't give you all the answers. We're still assuming x is between 0 and 360 degrees. What I prefer to do, instead of doing the sine inverse on this, I prefer to always go back to my unit circle. With my unit circle, what I'm looking at is if sine is -1/2, that means in my special triangle, and I'm just drawing just a, I'm not drawing anything nice there. Let's get rid of that. All right. If I draw a triangle, and I'm just talking any triangle, then I know if this is my angle, sine of -1/2 means I have to have the opposite side would have to have been a -1 and the hypotenuse too, because sine is opposite over hypotenuse. Now, where would I have the opposite side? Well, the opposite side, if you're thinking of anything in any of these quadrants, if I go this quadrant, this quadrant, this quadrant, this quadrant, all four quadrants, that's what we're dealing with, 0 to 360. And I draw this, well, my opposite side, would this be -1? If this is my reference angle, this side can't be -1. Same idea here. Can this side be -1? No. The sine relates to y, right? And -1 happens down here. And here we have an opposite side of -1 for this reference angle and this reference angle, don't we? And this would be the hypotenuse of 2. That would make this -√3 and this +√3. So what angle do we have here whose side opposite is the small one in the 30, 60, 90? It's the 30-degree reference angle, right? So 30-degree reference angle here and here would give me what angles? Well, let's look at that. One of my angles would be in standard position here to here, which is 180 plus 30. So what do we get? X equals 210 degrees. If I go all the way to here, well, I'm going all the way around to here, 30 degrees short of completing the circle. So that would be 330 degrees, and those two would be my solution. Now, if you did this with your calculator, you would have only gotten this one, and you'd had to find the other one. All right, it would actually, what it would tell you is if you punch this in, it would have told you sine x, if I did sine inverse of both sides. So sine inverse, let me write that out. What's going to happen, just so you're aware, the pitfalls of doing this the other way. If I had gone that traditional route and taken this problem, sine x equals -1/2, and done sine inverse of both sides, Sine inverse of this side. This side would have been x. This side, when I have sine inverse of negative 1/2, when I punch that in my calculator, it tells me negative 30 degrees. Well, negative 30 degrees is not between 0 and 360, so you would still have to interpret it to get this answer, right? Negative 30 degrees is the saying going backwards 30 this way, so that's the same as going forward 330, same terminal side, but it wouldn't give you this one. This is why that unit circle is so critical to know and to be familiar with those values and understand that when you saw that negative 1/2, that's going to be a unit circle value that I can find all the solutions for from 0 to 360. All right, let's do one more. All right, another example we are going to do. Let's do cosine x equals negative √2 over 2. So again, I'm going to take the unit circle approach completely now. I'm not going to rely on my calculator. I could check things on my calculator. I could do things like that. But let's take the unit circle approach to this and say, all right, I need an angle whose cosine is √2 over 2. In essence, I'm just looking at not positive or negative yet, just what has a cosine of √2 over 2. Well, hopefully you get familiar enough with these that you recognize that's a 45-degree reference angle, right? 45-degree reference angle. So now, in general, again, if I want to just talk about where this might be, it's going to be in each quadrant a 45-degree reference angle. Where is cosine? The next thing I would do when you start getting to this point is where I know you're right where I want you to be. √2 over 2 is going to be a 45-degree reference angle. I know that. A negative value with a cosine, where is cosine negative? Cosine relates to our x values, right? Where is it going to be negative? Over here and over here, right? Cosine is positive over here because it's the x value. It's on the positive x-axis. These would both have negative cosines. And so with a 45-degree reference angle going this far, that would give me x equals 135 degrees. Going this far, 45-degree reference angle is 45 past 180. That would give me 225 degrees. And I have both solutions that are happening between 0 and 360 degrees. Now, one last quick example. I'm not even going to get a new page. Let's see if you really are into this unit circle thing. If I said, let's do another cosine. Cosine x equals -1. Where on the unit circle is cosine equal to -1? Well, remember, the only place it can be zeros, ones, or undefined are on these quadrantal angles, right? The ones that are on our unit circle. Again, we're always thinking of this having a circle around it. I just can't draw it really well, so we're just imagining there's a circle there. We know that these are going to happen on these quadrantal points, on the quadrants. So where would our x value be -1? Well, that'd be right here, wouldn't it? So our x value would be -1 in one rotation, only one spot, right here. X equals 180 degrees. Any difficulty there? Acting like I'm giving a class lesson. So anyways, that would be the first type of equation that we are going to be solving. All right. Now, we're also going to be evaluating some others. Another type of example where it says evaluate. And in some ways, I think these are a little easier because it'll say assume here all angles are in quadrant 1. All right, so it could ask us something like this. Tangent of cosine inverse 4/5. So we have to think about this one again. The tangent is what we want. We want a tangent of an angle. This is telling us what angle. The angle whose cosine is 4/5. So where would I know an angle would have a cosine of 4/5? Well, that means if we have this, we know cosine is equal to, cosine of theta is going to be equal to x over r, isn't it? It's our x value over our r value. So that means we would be going out 4 this way, no matter what, because this is our x, this is our r. It would also tell us our radius is 5. It said assume all angles are first quadrant, so I'm drawing a first quadrant. So this is 5. So if I want the tangent of this angle, then I need this value here, don't I? I need my y value. Well, if I have this, I can use Pythagorean theorem, or I could know that this is a 3, 4, 5 triangle, right? We have certain triangles like 5, 12, 13s, 3, 4, 5s that are right triangles that show up again and again. But again, if all else fails, I could have said 4 squared plus y squared equals 5 squared. And I would have told me that y squared equals 9, right? Because 25 minus the 16. And that means y equals plus or minus 3 technically, but we're in first quadrant, so it's going to be positive. So I know y equals 3. So if I want the tangent of this angle, what would be the tangent of that angle? Well, if I know this is 3, tangent would be opposite over adjacent. So it's going to be 3 over 4. So again, let me recap that. They told me it's quadrant 1. They said they want the tangent of the angle whose cosine is 4/5. Well, if the angle's cosine is 4/5 in the first quadrant, I can just draw any just a general first quadrant angle and say that means the x value is 4 and the hypotenuse is, or the r value is 5. And then I can solve for this other side that I needed to find the tangent of this angle. All right, so let's do another one. Let's just scroll down a little bit, do the same thing. All right, let me do a different color so it just breaks it up a little bit. Cosine of sine inverse root 2 over 2. So cosine sine inverse root 2 over 2. Again, this is first quadrant. The angle whose sine is root 2 over 2. Well, we know that. We just talked about that. That's going to be a 45-degree angle, isn't it? More importantly, when we say it's root 2 over 2, we know that means the side opposite is going to be 1, and this is root 2, right? Because 1 over root 2 is where we get the root 2 over 2 from. So we have that. And we know that this is a 45-degree angle. So what is the cosine of that angle? Well, it's going to be the same thing, isn't it? Again, knowing our unit circle, that's going to be root 2 over 2. And we have that answer. All right, so let's do another one. One last one. We do this one. Let's do cosine, arc cosine, 2/7. All right, so this arc thing, arc cosine. When you say arc cosine, this is actually what the real function is called. They're called the arc functions. What the problem is years ago we started developing calculators, and arc cosine, 6 letters do not fit on a calculator key very well. So as a shorthand, they started writing this. Even though this is not technically the inverse of cosine, it's the angle whose cosine is, or arc cosine. All right. So again, why do you think that is? Probably arc length of cosine. Remember, we talked about unit circle. It's about the arc length and all that good stuff that we talked about in the beginning of the whole unit circle idea. When you have a unit circle, as we go around, those values are the arc length. So it's the angle whose cosine is the arc length of the cosine. That I think is the connection. So you'll see arc cosine, you'll see arc sine, and they're just asking this, right? That's what arc sine is. Arc tan, all of these have arc functions, and that's just tan inverse, right? So that's what we're dealing with. So this is the cosine of the angle whose cosine is 2/7. I'm going to give you a second to think about that. If you need to, pause, and you try to work this one through. The cosine of the angle whose cosine is 2/7. Go ahead and pause. All right, I'm going to assume you paused, and you're back now. Now, if you thought about this and said, all right, well, I can do the same thing. If cosine is that, then I can draw this and draw a first quadrant angle. And cosine means my x value is 2, and this is 7. So 2 squared plus my y squared will equal, what will it equal? 49, 7 squared. So 4 plus y squared equals 49. And you go through all this, and you get y squared equals 45. So y is the square root of 45, or 3 root 5, right? Something like that. Now, ask yourself, did I even need that? I did all this work, but if I really understood what's going on here, I need the cosine of this angle. The cosine of this angle is the adjacent side over the hypotenuse. It's 2 sevenths. And think of why. This is asking the cosine of the angle whose cosine is 2 sevenths. So the angle has a cosine of 2 sevenths. We want the cosine of it, 2 sevenths. These can be no-brainers if you understand how to read these. All right. So that's what we're doing with this, guys. I think we give you a couple of regular right triangle problems just as some review in this too. That's why the unit's called Solving Right Triangles in the book. It has that. But these are the ones that the ones I've gone through just now are the ones we really want you to know. So again, go through, do these. Again, make notes and ask us questions. As the year is going on, we're getting fewer and fewer questions. Make sure you are doing this authentically. You're letting yourself get it wrong. You're working through them. And if you're confused, you have to ask. That's where you really learn, guys, is when we're helping you correct your mistakes and lead you through these problems. That's where you're really starting to develop those connections in your brain. And then, of course, the last step that I always mention, go back and redo that problem on your own later on. Like later on in the day, the next day, go back on those problems that you would start in the previous day's work and do a couple of them again from scratch and see if you can do them. It's always a good kind of mental exercise, and it'll cut down on your studying at the end before a quiz or a test quite a bit because you're reconnecting those things daily. It puts them into long-term memory for you. All right. So that's all I have for you today, and that finishes this chapter. We'll be wrapping this up and going on into chapter 6 real soon. Have a great day.